Here we go. We have a question rotate by 90 degree. So you have given a square matrix. The task is to rotate it by 90 degrees in clockwise direction without using any extra space. So you have given this matrix and the output will be this, and we don't need to return an array, we just need to change the input matrix. So that's what this problem description says. So let me explain you with a visual representation what we want to achieve and what approach we will follow. So we have given, let's say we have given this 4 cross 4 and 5 cross 5 matrix. So this these cells will be placed here. Here means in this position, and these cells will be placed here. Here means these cells means uh, these four will be here, this 8 will be here, 12 will be here, and 16 will be here. Then these cells will be here, and these cells will be here. So a rotation or shift of cells will be uh, across the boundary only. So in the 4 cross 4 we have to do the rotation clockwise upon these cells, and then inside of this we have another box. So in the 5 cross 5 first we have this boundary, then we have this boundary, and we don't need to do the rotation for only one cell. So for 5 for 4 cross 4 and for 5 cross 5 we have to do the rotation for only two times. So same applies for if we have 1 cross 1 we don't need to do any shifting. If we have 2 cross 2, if we have 2 cross 2, so this is 2 cross 2 and this is 3 cross 3 itself. So we just need to do the rotation for only once. So how? So let's first understand the operations. For 4 divide 2 we got 2, and if we divide 5 by 2 we got 2 itself. So for the outer boundary, for the boundary we have a separate loop. So let's say its name is we will call it OP, operation, and OP is less than n by 2 and OP plus plus. So OP plus plus. So for this case 0 till 1, 0 and 1, and for this we have 0 and 1 also. So we're gonna apply for two times. So let's first understand the boundary itself. Let's first understand the boundary itself. We have this. So what it means is its cell is 0 0. So we have left boundary, its initial value is 0, and we have right boundary, its value is n minus 1, and we will not reach till r. R means boundary, boundary right side. We will not reach till r. We just need to traverse till here. These three cells will shift. One will be here, two will be here, then three will be here, then this four will shift to here. So we don't need to traverse till r. So we have a loop for this. So let me solve this question for only 5 cross 5 matrix. So you will get it. Now we have a little bit more space. So first we have OP. OP will reach from 0 to n by 2, and in this n by 2 is excluding, and inside of this we have another loop L, actually I will start from L and reach till R. R is excluding. Okay. Then L is here, R is here. So let's first pick up the points. What are the crucial points? First point is this, next point is this, next is this, next is this. So a shifting will be done between these cells, between these cells. So let me call this cell uh, top, top left, and this will be top right, this will be bottom left, and this will be bottom right. So what is top left? Top left will be array of. So first we pick this point, next we need to pick this point, next we need to pick this point. So what it means is our I, our row is same. How row is defined? Row is defined by L, and our I means column changes. Next, top, top row, top right. So first we need to pick 5, next we need to pick 10, next we need to pick 15. So how do we pick this element? In this, our column is same, column is R, R is n minus 1, and our sorry, yes, our column is same, and our row changes. So first row is I and column is R. First of all, our I is 0, so 0 and n minus 1. Next I will increase, I will go to 1, then 1 n minus 1, 2 n minus 1. So that's how it will work. Then we have bottom right, bottom right. What is this? This is n minus 1. First we pick this point, next we pick this point, next we pick this point. So in as you can see, our row is same and column changes. How row is defined? N minus 1 minus L. Why do we need minus L? I will tell you. Initially our L is 0, so it will just pick n minus 1. Next, n minus 1 minus, our column changes. Column first of all is this, next is this, next is this. So we need to write I here. So n minus 1 means last position minus I is 0, then it will become 1. So n minus 2, last row n minus 2 column number. Then n minus 3 column number. So that's how it will work. And let's talk about our last cell. Last cell is bottom left. So first it will pick this, next it will pick this, next it will pick this. So in this, our column is same, column is L itself. So column is L itself, and row is changing. How? So n minus 1 minus I. So first we have this n minus 1, I is 0. So it will be this cell. Next I will become 2, n minus 2, n minus 2th row with L. L means 0, 0, 0 column. So we have picked these elements. Next we need to do swapping. This will be placed here, this will be placed here, this will be placed here, and this will be placed here. So let's do the shifting. Here we have A L I. It means top right. In the top right, the element will be bottom left. Next, we have A I R. This is top right. The top right, the element will be top left. Next, we have this. So we have A of n minus 1 minus L n minus 1 minus I. This is bottom right. The element will be top right. The element will be top right because this element will come here. And at last we have n minus 1 minus I, and we have L. This element will become will shift to this cell. So the element will be bottom right. Bottom right. So let me do the shifting. 1, 5, 25 and 21. 1, 5, 25, if I'm not wrong, then 21. So we have picked this. Next we have to pick these cells. This, 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 and this. Then we change the elements. Then the element will be 16. Here the element will be 2. Here the element will be 10. And here it will be 24. So we have changed all 4 elements. Next cell will be this, 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 and this one. So the element will be 11. Here the element will be 3, and here I think it will be 15. Then here the element is 23. Next, we have to pick this cell, this cell, this cell, and this cell. So 6 will be here, 4 will be here, then 20 will be here, and here we have 22. So now you will get it why we don't need to travel till R, because this element is already shifted from here. So as you can see, this 1 till 5, this 1 till 5 line is initially here. Now it is shifted to 90 degree. So that applies to all the boundary cells. Next we need to go inside of this boundary. So our L increase and our R decrease. Our L increase and our R decrease. So now we have A, L and R. This is the top left. This is the top left. Because L and I is 0. I is L itself. So we pick this element. Next we need to pick this element. Next we need to pick this element, and we need to pick this element. This is top left. This is top left. Next we have top right. Top right. I is initially L. So L, this is means row. Row is same and column is R. Next we have n minus 1 minus L. So that's why we need to write minus L here, because now the bottom right changes to this. This is our bottom right. N minus 1 minus L. L is now 1. So n minus 2. N minus 2 and I is also L. This is n minus 2, n minus 2. So we have this, we also have this bottom left. So we need to change the values. So 17 will be here. 7 will be here. So then 10 will be, I think it is 10. No, it is not 10. It is 9. Yes, 9. And here we have 19. And that's all. So we have changed the values. Next, we need to change the value for this cell, for this cell, for this cell, and this cell. This is our last cell. The value will be 12. Here we have 8. Here we have 14. Here we have 18. So we are done with this. Next, we don't need to reach till R. We don't need to reach till R. So as you can see, this 7, 8 and 9 is initially here. 7, 8 and 9. Now it is shifted. Then we need to go inside. So now L and R is same. In this case, we have odd cross odd matrix, so that's why it is same. If we have even matrix, then L will exceed R. So that's why we only need to traverse till n by 2. Operation will go from 0 to n minus 2. So that's about it. This shifting and the element pickup is done inside the for loop, and outside this we need to increment L and we need to decrement R. So that's the overall code. So let's code this. We have N, we have L and R. Next we need to do the rotations inside the squares. So we have operations. Next we have our I loop. We pick up top left, top right, bottom right, and according to that we change the values. So that's how we change the values. I already told you how it is working. Next, outside of this we need to increment L and we need to decrement R. So let's submit this, and let's talk about time and space complexity. We have this code only, and this function, this for loop is work till n by 2, and this will work till n. So you can say the overall time complexity is n square. Yes, and space is constant because we need to change the input array. If you like this video, give it a thumbs up, subscribe to this channel. Thank you all for watching.